Okay, first problem is going to be factoring. This is a rule always, before you start factoring, look for a greatest common factor. 12, I can see right there that you can break it down, right? 112, you can do 2, 6, 3, 4. This is really what I was going for. Those factors. 75, we can break it down as well. I want you ladies, you have your calculators in here? So when we need to do calculations, you can help me. 75 doesn't have that many choices, but it's still, any number that ends in a 5, you always can divide that evenly by 5. So we'll have 5 and 15. And 15, we know we can break it into 5 and 3, right? So we have 3 as a common factor in both numbers, both terms. We're going to pull out the common factor, which is 3. So we have 3 times 4 will give me the 12, right? And then we have, if I multiply 5 times 5, will give me 25, right? So I still 3 times 25 will give me the 75. Oh, I forgot we have x as a common factor too. So we can pull out 1x. Now, if you take a good look to this, we have 2 perfect squares. So this is a special case called the difference of 2 squares. For this to happen, you have to have both terms to be perfect square, and in the middle, you must have a negative sign. That's the only way it's going to work. So what we're going to do is we're going to open a set of parentheses, find the factors of 4x squared, which is 2x. We're going to place in the first place of each parenthesis. One parenthesis has to be negative and the other one has to be positive. The order doesn't make any difference. And 25 is going to be 5 and 5. We still always have to bring down that 3x. And that will be your answer. Yes, 2 times 2, 4. A perfect square, how do you figure out it's a perfect square? 1 times 1 is 1. 2 times 2, I think it's reading me. 2 times 2 is 4. A number multiplied by itself, it will give you a perfect square. 5 times 5, 25. That's why that problem is a difference of 2 squares. Are you good? Okay, next one. Factoring by grouping. First, I look for common factors. There are no common factors. By grouping, they mean the method AC. That means multiplying A times C. And if you remember, this is A, this is B, and the last number, your constant, is C. So we're going to multiply 3 times 6. Which is going to give you 18. So we're going to write 6x squared minus the terms that, let me see. We need to find the factors of 18. I forgot that part. The subtracted together is going to give you negative 7. 2 times 9, oh, right there. 9 minus 2 will give you 7. So we're going to subtract 9x minus 2x minus 3. We need a positive 2 to get a negative 7. The higher number has to have the sign that you're looking for. You're looking for a negative 7. That's why the higher number, which is 9, the two terms that I just found, right? The higher one has to have the negative sign in this case. Now, by grouping means you break it in half. I use a different color. And you're going to look for the common factor. In these two, we have 3 as a common factor. So 3 out. 3 times 2 will give me the 6. X is a common factor too. So 2x minus 3. You see how I got that, or you want me to do a step by step? You got it? You got how I got the 3x and the rest? Okay. Now, the other side, we don't have anything in common, but always I can pull out a 1 as a common factor. And I rewrite the right side. 2x minus 3 inside parentheses. If you notice, the checking point is that when you finish doing this and your 2 parentheses are exactly the same inside, that means you did good. If not, you have to go back and check and find where you went wrong and fix it. So when my 2 parentheses are the same, I rewrite one of the parentheses and I open a second set of parentheses, and I'm going to put inside that second parenthesis what is left out outside. So it's going to be 3x plus 1. And that will be your answer. Good? Okay, we're going to number 3. The same thing. Look for a common factor. We have 54 and 128. At least 2. When you don't know on top of your head which number could be, and the two numbers and the two terms end in an even number, you at least can go by half, dividing by 2. So what is half of 54? 27. So I'm going to pull out a 2. It's going to be 27x cubed minus, if I divide 128 by 2, 54. 64. Okay. Thank you. Now, if you look at this, when the ends in a 0 or an even number, always by 2 is going to give you an even number, not decimals. 0 or even numbers. So if a number, a big number ends in 0, 2, 4, 6, 8, you know that you can go at least by half. This one is not so easy to notice what is going on, but when you see the cube, x raised to the 3rd power, trying to think of, oh, maybe it's the difference of 2 cubes, and that is what is happening in there. And to double check if those numbers are perfect cube, you can go in your calculator and do the cube root. The cube root of 27 is going to give you 3, but you can do it so you can double check and you learn how to do it. And cubic root of 64, and it's going to give you 4. But if you do it, you learn how to check for it. You got it? You see it? The cube root of 27 gives you 3, right? Ah, that one doesn't have a cube root. If you get a graphing calculator, you can do the cube root. No, this one, I don't see it. Maybe, oh yeah, it's there. If you use the yellow, how you can use the function? That one? No, backwards. You clean that. Go first this and the cube root, and now 27. Hit enter. You see? 3. That's a way to check for it. Do you remember the formula for the perfect cube, the difference of cubes? Nope. Okay, is this a minus b inside parentheses, and then you open a second set of parentheses, and it's going to be the first, which is a raised to the second power, plus a times b plus b raised to the second power. So that's the formula. And because we know already, we check 27 is going to be 3. For 64, your number is going to be 4. So your A is going to be 3x and your B is going to be 4. Now what we need to do is replace those numbers in here following what the formula is telling you to do. It's straightforward. So first I'm going to write 3x, that's my A, minus B, which is 4. Open the parentheses. A, which is 3x raised to the second power. So I'm going to have 3 to the second power, x to the second power, plus A times B. So that's going to be 3x times 4, plus B squared. So 4 raised to the second power. Now I'm going to clean that up a little bit. The first little parenthesis, I cannot do anything with it. So I just rewrite it. Open the second one, 3 times 3 is going to be 9. So 9 to the second power, plus 3 times 4 is going to give me 12x, plus 4 times 4 is 16. And that is your answer. You cannot go any farther than that. So basically, this problem, in my opinion, is to remember the formula, learn how to figure out which one is the number for the perfect cube, and plug it in.
So the 3x and the 4 are the square root of both numbers?
The middle? What is your question again?
Those numbers are the square root of 27 and 64?
A square root, no, cube root. Let me show you my calculator so you understand what I'm talking about. I got a graphing here, graphing calculator. If I go to math, it gives me the choice. That's exactly the same way it works the regular calculators. You have number 4, the option is the cube root. So I go 4. You see 3 beside anything else, or the normal 2 that we always have, that gives you 3. If you do the same thing for the, what is the other number, 64? No. Yeah, 64. 64 is going to get you 4. That's the way to figure it out. So it's hard to remember the perfect cubes. So that's what I'm saying. When you have the variable with it's raised to the third power, and you cannot pull out another x because it's not a common term, think about it may be a perfect cube. So you go to your calculator and you check. Are we good with this one? Number 5. Okay. To figure out if those numbers are a solution of this system, we have to substitute. Remember that always here is going to be your x and your y. So you're going to rewrite it and you're going to substitute x for negative 22 and y for 13. At the end, when you multiply, subtract, and you get the left side to be equals to the right side of the equal sign, if you get negative 1, that means it checks. It is a solution. You guys are my calculator ladies. So 3 times negative 22? Negative 1? Plus 5 times 13? What happened here? Negative, different signs, we subtract, keep the sign of the largest number, so that is going to give me a -1 equals to -1. That means checks. -1 is equals to -1. Now we're going to do the next one. We're going to do exactly the same thing. -2, open parentheses, -22, -3, open parentheses, 13. That equals to 5. Negative times a negative give me positive, right? So 2 times 22 is going to give me a positive 44 minus 13 times 3 times 13. How much is that? Yeah, 39 equals to 5. If you subtract that, different signs subtract, get the sign of the largest number, so my answer is going to be positive. What is doing this? Yes, sorry. The pen is doing something weird. Let me see if I can fix it. Okay. Yes, the 44 is positive because negative times a negative is going to give me positive. And then a negative times a positive gives me -39. The signs are different, so I'm going to subtract, keep the sign of the largest number. The largest is 44, which is positive. So our answer is going to be positive. 44 minus 39, 5. So it gives me that 5 equals to 5, which checks. That's correct. Mm-hmm. It is. So now, number 6, you guys good? Fractions. That looks kind of crazy, but it's always a good way how you can fix fractions, and I'm going to show you one. This looks kind of scary. You need to solve for a system by elimination, and you have 4 fractions in there. So, first thing, what do they have 3 and 2 in common in the first equation? We have 1 over 3 x plus 3 over 2 y equals to 3. Really, anything in common. But 2 times 3 is 6. So I'm going to multiply everything, meaning everything. That's why you put the parentheses in there so you don't forget. You're going to multiply everything by 6. So 6 times 1 is going to give me 6 over 3x plus 3 times 6 is going to be 18 over 2 y equals to 3 times 6, 18. I can simplify those fractions. So 6 divided by 3 is going to be 2x. 18 divided by 2 is going to give me 9y equals to 18. So that looks a lot friendlier than the original one. We're going to do exactly the same thing with the other equation. So the other one I'm going to do in green so we don't get confused. So I have 2 over 3 x plus 1 over 4 y equals to 1. The same thing. 3 and 4, nothing in common. We have to multiply them together. That is going to give me 12. So I'm going to multiply 12 by everything in here, every single term. So 2 times 12, it's going to give me 24 over 3x plus 12 over 4 equals to 12. 12 times 1. Oh, the original 12, the gray one, when the denominator, the bottom part, they don't have any common factor, you just multiply them. So 3 times 4 gives me 12. That's why I'm multiplying everything by 12. That's the way to get rid of the denominator. Now, I have 24 over 3. What will be that? I have AX, 12 divided by 4. 3. Oh, I forgot the Y. Thank you. She was so sweet and nice, like 3. Why? Like, come on, lady, get it together. Don't forget your variables are wrong. Okay, now these look a lot better than the crazy fractions that we had before. Now we're going to do the asking you to use elimination. So what you do is you write one on top of the other one. That's what I'm doing now. And you're going to choose what you want to eliminate. Whatever you choose to do is fine. We don't all think the same way and work the same way, but if you get the right answer, you're good. I would like to multiply my 3y. I'm going to choose the green equation, the second one. So I'm going to multiply everything by a negative 3 so I can cancel y. So negative 3. Please doing it again. Don't erase my work. A x plus 3. Okay. Now I'm gonna distribute the negative 3 to every single term. So negative 3 times A, I'm gonna get negative 24 x. Negative 3 times 3 is going to give me negative 9y. Negative 3 times 12, negative 36. Okay, the whole idea was to cancel y, and that happened, so we're good. Now we're going to combine the x's, different signs. Subtract, keep the sign of the largest number. The largest is 24, so it's going to be negative 22 equals to negative 36 minus 18. What did you say? No, you need to subtract them. The signs are different. You subtract, keep the sign of the largest number. So my answer is going to be negative. Oh, Lord. 18, exactly. Negative 18. Now, to solve for x, I need to divide both sides by negative 22. This cancel. Now I have x is equals to positive because negative and a negative give me positive. If I divide 18 by 22, it's not going to go evenly, but do at least half and half. You know that you can divide by 2. So it will be 9 over 11. Yes. You're doing like addition and subtraction. These two, because I have 9x and negative 9x, cancel. These two, I combine it, the x. Because they have different signs, I subtract. So 24 minus 2 is going to give me negative 22, right? And the same thing you do with numbers, the constant. Negative 36 and 18 get subtracted and keep the sign of the largest number. Now we have to figure out, we have x already, right? So we have to find y. I'm going to pick the easiest, whichever equation you pick to substitute, you're going to get the right number. Which one you want to do, the blue one or the green one? Blue one. Okay, we're going to substitute x on the blue one. So that is going to, let me choose maybe red. So we have 2, and I'm going to substitute 9 over 11 plus 9y equals 18. So 2 times 9 is going to give me 18 over 11 plus 9y equals 18. So I'm going to subtract negative, I'm going to subtract 18 over 11 both sides of the equal sign. 18 over 11. So these cancel. Now I have 9y equals 18 minus 18 over 11. If you notice something here, every single term has a common factor of 9. So we can pull out the 9 and make the numbers smaller, so that will be easier to work with. So I'm going to divide everything by 9. Why you don't? Come on, work. So that will be, if I pull out a 9, that is going to give me y. I want to stop working. Oh, chop down. It shut down. One node shut down. So we pull out a 9. If we divide 9 over 9, we're going to have 1, right? And then equals 18 divided by 9 is going to give me 2 minus, this is going to be 2 over 11. The same thing is happening over. Yes, the fraction is not going to go away. I pull out a 9. I pull out a 9 as a common factor. So you always keep whatever you pull out as the greatest common factor in the front out in the parentheses. So to combine those two fractions, we have to have the same denominator. Let me get my colors out again. So we are going to multiply top and bottom by 11. So we can have the same denominator. So we have y equals 22 over, no, sorry, 44 over 22. I was going ahead, thinking about the denominator. So 44 over 11 minus 2 over 11. Now we can subtract those two. We got 42 over 11. I was trying to do it quick in my head. Did I do it wrong? It's a 22, I'm sorry. Yes. You know, this thing not working correctly is kind of getting me. Okay. Now it will be 18, right? Yeah, that's your answer. It's 20. Why?
When you divide 22 divided by 11, isn't it 2?
Let me see if I can make it smaller so we can see. No, we are not dividing. Remember we were here, right? So we move the 18 to the other side of the equal sign to the right side. But they're subtracting each other. 18 minus 18 over 11. So it's a subtraction, it's not a division. We're subtracting fractions. That's why we make the denominator to be the same, multiply top and bottom by 11. Now we have 22 over 11. We could simplify that, you were right, but the idea is to have the same denominator so we can subtract the fractions. So we subtract the 22 minus 2, 20 over 11. Number 7. Solve the following system by substitution. When they ask you to do substitution, it's because they want you to solve for one of the variables and then plug it in the other equation. So I'm seeing that y is by itself in the first equation, so I'm going to solve for y. So I have 2x plus y equals to 4. So I'm going to subtract 2x in both sides of the equal sign. Cancel. Now I have y equals negative 2x plus 4. So I'm going to plug in this y into the next equation, which is 3x minus 4y equals to negative 5. So I'm going to substitute y negative 4, open parentheses, negative 2x plus, oh, you know what I can do? Negative 2x plus 4. Equals to negative 5. Now I'm going to rewrite everything. Now I'm going to distribute negative 4 to every single term. Negative 4 times a negative 2 is going to give me a positive 8x. Negative 4 times a positive 4 is going to give me a negative 16 equals to negative 5. Good. Now I'm going to combine like terms. Oops. Exactly. So I'm going to get what? How much is that?
Oh,
11x minus 16 equals to negative 5. I was messing with you. Plus 16, both sides, plus 16. These cancel. 11x equals different signs. Subtract, give the sign of the largest one. So that is going to give me a positive 11, right? To leave x by himself, because we're solving for x, we divide both sides by 11, cancel, so we have x equals to 1. That was an easy, nice number. Now, you take 1 and you can plug it in whichever equation you want, and will give you your y. Which equation you want to use, the first one or the second one? Yeah, the first one, 100%. So we're going to write 2 open parentheses, 1 close, I was doing that thing again, equals to 4. So 2 times 1 is going to be 2 plus y equals to 4. I subtract 2 in both sides of the equal sign. I was doing that. Yeah, sorry, it's rewriting and erasing. Give me a second. Okay, this is 4. So the 2 cancel, now I have y equals 2. Good. We're going to move to number 8. What they're asking, solve the following system by graphing. Always when you're graphing, keep in mind this equation, y equals mx plus b. That is your slope-intercept. Remember, always your m, the number right next to the x, the variable, is going to be your slope, and b is going to be your y-intercept. So if we solve both of them for y, I'm going to add 2x in both sides of the equal sign. Cancel. Now I have y equals 2x plus 2. I'm going to do exactly the same thing in the other side. I'm going to subtract 4x both sides. Now I have 2y equals negative 4x. I'm going to divide by 2, cancel. Now I have y equals negative 2x. This way is a lot easier to graph. The second equation doesn't have a b, that means it's 0. So the y-intercept is right there. Okay. And my slope, I'm going to write it. My slope is negative, and remember it's rise over run. So I'm going to go 2 up and 1 to the left. 2 up and 1 to the left. And here is really hard with this smart board, and I'm not good at drawing anyways. But more or less, something like that is going to look like. It goes up and left because it's negative. When it's positive, you go up and right. When it's negative, you can go up and left. Yeah, that's it's going. It's going down. You have only a tiny piece of the graph. If you cover the graph from left to right, you're going to see that it's going down. You see now? Cool. I got you with that going left, right? It's because it's negative. And now the first equation. I'm just teaching you how to like roughly graph it when you are in a test. So you have to do it on paper. We can find it in the computer. We're gonna find exactly the numbers with algebra. This is the graph, and just like to have an idea how it's gonna look like. Then we have the second equation with this 2 is my, let me change the color. 2 is my y-intercept. Oh, it's going by 0.5. I didn't notice that. So 2 is right here. And then my slope is 2 over 1, and it's positive. So I'm going to go left and down because it's positive. 1, 2, and 1, more or less. Not always. When it's positive, you're talking about the slope. When it's positive, you go up and right. But because I didn't have no more space to go up, I can go down and left. It's gonna make the same effect in the graph. But it's negative. You have to go. One of them has to go backwards. If I'm going up, I have to go left. Or if I'm going down, I have to go right. One of them has to be the opposite to make a negative. Okay, how to find the numbers graph algebraically? Try to make the screen smaller. Oops. Stay there. Okay. For this, you have to make your box X and Y, and you can find exactly the points that you need. I always pick the same easy numbers. 1, 0, 2. So if you substitute this one, doing the blue one, y equals negative 2 times 1. That is going to give me a negative 2. So when x is 1, y is going to be negative 2. is I do 0, it's going to be -2 times 0 equals to 0. So when x is 0, y is 0. And then when I substitute x for 2, I'm going to get a -4. That's a way to find exactly the points so you can graph it as you're doing the test in the in the computer. We're gonna do the same thing with the first graph, the first equation. So I'm gonna pick the same numbers, 1, 0, 2. So I'm gonna substitute by 1. 2 times 1 is 2, plus 2 is gonna give me 4. So when x is 1, y is gonna be 4. Two times 0 is gonna be gone. So when x is 0, y is gonna be 2. Now I'm gonna substitute by 2. 2 parentheses 2 plus 2. 2 times 2 is 4 plus 2 is gonna be 6. With those points, you can go exactly to the graph and plug it in. They did this graph on purpose by 0.5, so that means you should use 0.5. But that will give you a good idea how to graph it. We good? Number 9. Solve the following system, any method. Which method do you want? An elimination, substitution, graphing? Yeah. Anyone would be easy. Substitution will be easy because that one is kind of already solved for y. 3y equals 6x plus 9. We can do anyone. Substitution? Yeah, substitution is going to be the easiest. So here we divide by 3 every term. So 3 cancels with the 3. So we have y equals 2x plus 3. So we're going to substitute y into the other equation. So we have -2x plus whatever we have in here, which is 2x plus 3 equals to 2. Now we're going to combine like terms. -2 plus 2, -2x plus 2x is going to cancel. And we have 3 equals 2, which is not solution. We don't have a solution here. So this one, 9. Yeah, no solution. So in this one, you have to write it out. No solution. How to know that? 3 is not equals to 2. So that cannot be an answer. That is showing you there is no solution. Infinite many solutions. Yep. Okay, this is a typical question of tests and quizzes and your homework everywhere. How to know if you have only one solution? If you solve it and you ended up with the variable to say x equals to a number, any number, x equals to 0, x equals to 1, that means you have one solution. It's going to be that number, right? No solutions, zero solutions, what happened just now, right? Is no in overlap, is the lines are parallel to each other. What happens when the lines are just parallel to each other? It's not going to be an intersection. When it's not an intersection, it's no solution.
So no intersection, no solution.
Uh-huh.
Would that be for graphing or algebra? Instead of graphing.
Mm-hmm. Parallel lines. Or también could be non-overlapping. You know when we do the inequality and you have to do the chatting, and you don't have overlapping, that is that. When it's algebraically, is what we have. I say, but we're not writing out something like this. That's just an example. 3 over 2. They are not equal. 3 is not equal to 2, so they are different. One solution, as I said before, a variable equals to a number. Graphically, when the lines intersect, that point where the intersection is happening. Infinite solutions, when you have something like 0 equals to 0, or any number equals to the same number. And infinite many solutions is going to be graphically parallel lines and overlapping.
I don't mind writing. No, you're good. I like writing.
Number 11. We're gonna go now for the word problems. Andy earned $1,400 during the summer. He invested part of the money at 20% and the rest at 5%. If he received a total of $115 in interest at the end of the year, how much was invested at each rate? So we have money that was invested at 20%. Remember, always when you work with percentage, you have to change it to decimal. You move the decimal twice to the right, to the left, I'm sorry. So that is going to be 0.20. And then we have another amount of money that was invested at 5%. And we're going to move the decimal again twice to the left. So that is going to give me 0.05. This is a good idea to keep in mind. If you're working over and over in a system of equations, when you get to the part where it's a word problem, gotta be something related to what we just finished doing, a system of equations. So how we can make this to be a system of equations? Say that again? Yeah. X plus y equals to what? Yes. One amount of money plus other amount of money equals the total money that I received, which was 1,400. And the second equation, perfect. And the total earning, which was 115. Okay. We are gonna do elimination. You can try any number that you think that it will work for you. I'm gonna go for 20 in the second equation because I know that it's gonna make my life a lot easier. So if you multiply 20 times 0.20, what you will get? My calculator friend. That sounds nice, right? And then 20 times 0.05, 25. Are you sure it's 25? One. And then 20 times 115? 21? 2,300. You guys, I'm already going nuts with this and you are not helping. Okay, now you know what? I forgot. Multiply by negative 20. So everything is going to be negative now. That way I can eliminate. So I'm going to rewrite the first equation. What happened now? I can cancel the y's. And now I'm going to combine my x's. Negative 4 plus 1 is going to give me negative 3. X equals to 2,300 minus 1,400. Yeah, it's going to be negative. Is I divide 900 by 3? Yeah, it is a negative 3 here. For negative and the negative, it's going to give me a positive, so I know that. How much? 300, okay. So I know my first amount of money invested was 300. You can go ahead. I'm gonna give you a shortcut. If the total amount of money was 1400 and you figure already the one amount is 300, you can go subtract 300 from the 1400 and the difference is gonna be Y. But we can prove it. That's the cool part about math. We can prove everything. Oh, about everything. Whoosh. So we're going to go here and we're going to take the easy equation, which is x plus y equals to 1400, right? We're going to substitute. Tell me, what is that?
No, when you said subtract that from 300,
1400 was the total amount that I received.
when you subtracted, it gives you
1100. Yeah, that would be y. But I'm going to prove it.
okay. No, I'm asking.
Yeah. No, it's good. Subtract 300 both sides of the equal sign. This cancels and I have y equals to 1100.
How did you get the negative 20?
Yeah.
You thought about a number that was bigger?
If you don't come out with a number like that in the test, like I'm not too much in the favor of like already knowing which number is gonna be perfect. But if you are taking the test and you something like this drop, you don't have to know the perfect number because that's not easy to figure out 20, negative 20. You can do maybe multiply everything by negative 0.20 to the top one, so that will allow you to cancel your x's, you see? Or you can multiply by, to cancel the y, you can multiply on the top one by negative 0.05, and that will allow you to cancel y. And then you will go from there. You will have decimals, but it's not a big deal. You can use a calculator. Yeah, no longer. It's going to be just like, not easy to your eye as this one, but you always can do it. Good? 12. One number is 5 less than another number. 4 times the first number is 2, less than twice the second number. What are the two numbers? Problem number 13. If you get to set this up, it's always the same. When you get a type of problem that you're selling something, an amount or tickets, it's a typical problem that always, every semester solves. If you remember how to set it up, you're good to go. Always find a variable. You can use anything. I always like to stick to x and y because that's the one that we use the most. So I'm going to call x to my adults. But you have to remember that so you keep a track of what you're doing. And y are going to be my children. Knowing that, we're going to set the equation. They're telling you the adults and children all together were in total 100. So that's going to be x plus y equals to 100. The same thing. We're working with system of equations. We have to come up with another equation. So the second part is telling you the adult tickets cost 3. So we're going to do 3 times x plus children's tickets cost $1. So that's plus y. And they're telling you the school collect at the end 220. How many adults and children attend? They want to know the total number of children and adults. So we can do this. Elimination will be the easiest. So I would like to multiply the second one by a negative. So that will give me negative 3, negative y, negative 3x, negative y, negative 220. I'm going to revise the first one, x plus y equals to 100. That allows me to cancel y. Now I have 4x equals to negative 120. Do you got the same numbers? Now divide 120 by 4. Oh, I forgot something. I forgot this negative in here. I forgot the negative in the front. Let me fix that. That is a negative 3 plus 1. That is going to give me a negative 2x, right? Divide by negative 2, divide by negative 2, and that is going to give me a x equals a positive 16. Yeah? The same thing as before. If your total number is 100 and you figure out 60 already, the difference is going to be 40. But we always like to double check and do the work algebraically. So we're going to go to the easy equation, which is x plus y equals 100. We're going to substitute x by 60 plus y equals 100. We're going to subtract 60 in both sides of the equal sign. Cancel. Now we have y equals 40. So that means your adults were 40 and children's were 60. Number 14. You're fine. And this is the last one. Well, we skipped 12 for now, so you're missing only 2. You're welcome. Anytime. I'm sorry for all the craziness. So solve the following system of linear inequality graphically. So the same thing. I will go and solve for y. I have x minus 2y less than 1. Instead of solving for y, I'm going to start by subtracting x in both sides of the equal sign. That cancel, which is not working. Negative 2y minus x plus 1. Now I'm going to divide by negative 2. Every time I divide by a negative number, I need to flip the sign. This. So this cancel. Now I have y greater than positive 1 over 2x minus 1 over 2. Do you know what I did 1/2? Yes? Okay. Good. That is the equation that we're going to use to graph. So now the second equation is 3x minus y greater or equals to 3. I'm going to subtract 3x on both sides of the equal sign. This cancel. Now I have y, negative y greater or equals to negative 3x plus 3. I'm solving for y, not for negative y. So I need to multiply everything by negative 1. You can divide or multiply. I like multiplication better than division. So erase everything again. Let me write it quickly. What did I have in there? Negative y. Okay, I got it. It kind of look weird, but it's there. Too much space in between. Okay, I'm going to distribute the negative. I want a negative y. So now I have y less than or equals to 3x minus 3. Okay, if I'm going to graph, I always go for my y-intercept. That is half, negative half. So I'm going to go about here, and I know my slope is right over wrong, 1 over 2. So I'm going to go 1 up and 2 to the right, 1, 2. So here, half up and 1, 2. So about here. More or less, that's my line. And then the other equation is negative 3. Negative 3, and my slope is 3 over 1. So I go negative 3 is right here, and my slope is 3, 1, 2, 3, and 1 to the right. Right here is positive the slope. And 1, 2, here. 1, 2, 3, 1 to the right. So more or less this is my line. It's not working. Okay. That is how it should look like. Now the shading part. For that one, the negative 3 says that y is less than, so we're going to go what it will be underneath. And the other one is y, yeah. So y is greater than, so we're going to do maybe red. Y is greater than, so it's going to be the other side. It's going to go going up, right? This way. But the overlapping part is this one. All this part is overlapping. So our answer is that part. For this, you can make the table too and find exactly the numbers, so your graph look more precise. Even though I didn't look for the table and find the numbers, it's there. The intersection is there. It's 1, 0. So that will be your solution. Problem number 4, long division. Always look for a common factor. We have u in every single term in our numerator, and we have u in the denominator as well. So we can pull out an u as a common factor. So we're going to end up with u minus 1. Move this to the bottom so we can have more space. So we're going to have u minus 1, and then u4 plus 2u to the third plus u to the second plus 3 u minus a. How to get u to the fourth? When we have u, we multiply u to the third. When we multiply variables, we add the exponents. So u to the third power times u is going to give you u to the fourth power. That's what we're looking for. And we flip the sign. Now it's going to be a negative u to the fourth power. We cancel the first term. That's what we're looking for. So when we get to do that, we're on the right track. Now we're going to multiply u to the third power times negative 1. That is going to give me a negative u to the third, and I flip the sign, which is going to give me a negative u to the third power. We want to combine them. different signs. Subtract, keep the sign of the largest number, which is positive. So it's going to be 2 minus 1. It's going to give me u to the third. I bring down the next term, which is a positive u squared. Now, by what number or variable I need to multiply u to get u to the third power is going to be a positive u squared. U squared times u is going to give me u to the third power. We flip the sign. That is going to give me a negative. So I'm able to cancel the first term. Multiply now u to the second times negative 1. That is going to give me a negative u to the second power. I flip the sign, which is going to be positive.